Okay, everybody, we're going to continue with our notes on moles. And so now, if you remember right, before we were using this top part right here, we were using molar mass to help us find how much mass is in a mole or vice versa. And those were problems 1 through 4. Okay, so we spent that time already. So now we're going to start with the different types of particles. So we're going to be using again the mole, and we're going to be checking it out with the number of particles, or we're going to be going backwards. Okay, so it says how many formula units are in 0.67 moles of NaHCO3. So that's sodium bicarbonate. The best thing about this one is that, remember, molar mass is when we have to do all that calculating, right? Now we're not. We don't have to do any calculating when we're on this leg of it, so it's pretty nifty. But it is sometimes hard to get the calculator work for us, so we need to make sure that we punch everything into the calculator perfectly. So how many formula units are in 0.67 moles? So we'll write what we're given and put it over 1. Don't forget your units. Okay. Okay. And now we know that there is 1 mole, again, because it says 1 mole in the center here. 1 mole of sodium bicarbonate, because we need those moles to cancel out. It's got to be placed down here. And then how many formula units are there? There are 6.02 times 10 to the 23rd. Hold on. Times 10 to the 23rd. This is that Avogadro's number of that video that we watched. And this is the number of formula units. Okay? So, how do we punch that into our calculator? You probably need... So, of course, we're going to go and multiply straight across, right? And our moles are going to cancel out on this, so that's nifty, and that's the purpose of how we set it up. Okay? Well, let's just go ahead and talk about how do we plug this in. So, it's going to be 0.67, okay? And then you'll press the times button, of course. And then you got to do 6.02, and don't press times 10 or anything like that. Press the EE button. The E button is right above the 7. You got to do second. And it says EE on it, but in your display it'll just be E. Okay? And then you punch in 23. So this EE button is times 10 to the, and then whatever value that you put after it. So let's go ahead and punch that in here. 0.67 times 6.02. EE 23. Notice that it only has 1 E in your display when you write it out. That's great. That's great. Did you get 4.0334 times 10 to the 23rd power? Because that's what we should have gotten. Okay? If you were off by 10, like let's say that the last number is a 24 or else a 22, you might have punched in times 10. If you got my yellow calculators, there's a X10, and then it's got like a little N as a superscript in it for a button. Did you find it? Okay. So that's the button that you placed instead of EE. Okay. And what do we get here? 4.03. We need to have 2 sig figs, so it's 4.0 times 10 to the 23rd. Okay, and then we got to have formula units. Okay. Okay, so again, we went from moles, we were going in this direction, right, to particles. So sometimes they don't tell you which particle it is. It might say particles up here, so you have to know which one is it. Is it ionic, and then you have to do formula units? Is it just an atom, then you have to write your number as atoms? Or is it a molecule where it starts with a non-metal, and then you have to know which one that it was? Okay, well, let's try it backwards now. Now we're going to be going from particles to moles. Okay, how many moles are in a sample of NaCl containing 5.84 times 10 to the 24th formula units? So 5.84 times 10 to the 24th formula units all over 1. Okay, and so you know the formula units have to go down here to cancel out. And we're going to moles, so that'll have to be up here. So 1 mole equals how many formula units?
6.02.
Good job. Avogadro's number. Good job. So 6.02 times 10 to the 23rd. So we really need to be careful on how we punch this one in. That's ugly. Let me fix that. That's not a negative there. Shoot. Okay. So that looks better. So let's go ahead and punch that in. Notice that these two, the two numbers in the beginning of your scientific notation, that they're pretty close to each other, and that this means that this would just be off by 10. So make sure that your numbers are making sense to you. So I got 9.7, and then I got to put a 0 there, and then that is just in moles. Good morning. Thank you. Okay, so that's how we do these ones on this leg. Now, again, the best thing about this is that you do not have to calculate molar mass. Okay, this leg is even nicer because it's not a scientific notation. So it's even easier to do. Easier to do with the calculator, right? Okay, so now we're going to be using, never mind. Now, how many atoms are in 1.72 moles of iron? So let's try this one out. Write what you're given, put it over 1. Set it up yourself here for a minute. Let's just take a moment and do that. And I'm going to pause the video here, and you guys do that at home. Okay, so moles cancel out. Got it set up like that. Perfect. And so you just got to punch that into the calculator. Did you get 1.035 blah 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 times 10 to the 24th power? 1.035 times, that kind of makes sense because when you look at these two, they're going to be multiplied, they're going to be around 10, right? And then, so then you make it a 1 instead of a 10, so this number is going to go up by 1, which sounds really good. So it sounds sensible when you look at just the numbers alone. If you ever get anything with a 46 up here, or something like that, then that means that you multiplied when you should have divided. Something like that could have happened. If you ever get a negative number up here, that means that you also did not stick it into your calculator right, or else you have this flip-flopped. Okay, so your number should always be in the positive 20s. I suppose if you got a really crazy book question, that it might be low 30s, but I mean they should always be positive 20s. Okay, so that's how many atoms are in 1.72 moles of iron. Okay, now we're going to talk about this leg over here. Okay, volume. So this is really cool. Avogadro actually himself, he was part of this thing where he figured out that all gas will just take up 22.4 liters of whatever atom or molecule or formula unit. Okay, it takes up the same exact space no matter if it's a molecule or it's an atom. And that seems kind of counterintuitive because you would think like, hey, if it's a bigger molecule, like if it's a really big molecule versus a very tiny atom, that should take up more space, but it doesn't. All of those are like little points. I mean, they're all still so small, but they take up a certain amount of space. Now, if you heat it up, it's going to take more space. Okay? If you have more pressure outside, it's going to take less space. So they say that this is at standard temperature pressure. So all these problems that were given are at STP. Otherwise, it isn't 22.4 liters. So when students get in the stress of a test, then what do? They ask me, well, what is STP? What is STP? Because they didn't see it because they weren't ever worried about it before. But then when you get a test, you get stressed. You know how that is. So all of these, for this 22.4 liters to work, it has to be at STP. So let's go ahead and we'll start with what we're given again. So we got 0.09 moles. Okay, and then we're going to put that over 1. Okay, and we know moles have to go on the bottom. Always 1 mole. And this is where it's really nice. It wants to know how many liters. So that's going to be this leg of it. So it's going to be 22.4 liters. Okay, of carbon dioxide, excuse me. Okay, they want to know 0.09 moles of it. Okay, so we can only have one sig fig in our answer, but let's go ahead. This one's a pretty nice one, isn't it? So 0.09 times 22.4. And I get 2.016 liters. And again, we can only have one sig fig in this, so it's just 2 liters. Oops, 2 liters. Okay, questions on that one? If you're thinking, wow, this seems like the easiest one, you're right. It is. Yep. Okay, let's try another one of these. Okay, again, it doesn't matter how big that the molecule is. It doesn't matter at all. Okay, but we need to go ahead. We're just going to go through 9. Okay, and I'm going to run out of time. So let's set it up. Put what you're given. Put it over 1. Okay, and then set up the rest of the next ratio. I'm going to press pause here. Actually, we're going to talk about this one tomorrow. So I'll see you later. Have a great day. Bye.